Hello and welcome to this episode of the Optimising Human Performance podcast. I'm Martin Jones.
And I'm Jonpaul Nevin. In today's episode, we're going beyond the physical limits and talking about the role that mental fatigue plays in performance.
I was the first one to actually test whether mental fatigue could have a negative effect on physical performance. And we found that the impact of prolonged mental activity on high-intensity endurance performance was as bad as pre-fatiguing the leg muscles on a cycling task.
Professor Samuele Marcora has been conducting pioneering research on mental fatigue for decades with some surprising results.
Strong emotions, especially if you have to control them, like soldiers do most of the time, can be mentally fatiguing. Even controlling a relatively mild emotion had a negative effect on physical performance.
We find out exactly what mental fatigue is, how it impacts performance, and crucially, what can be done to combat it.
Physical training is mentally demanding. So when you do the physical training, you also train people to be more resistant to mental fatigue. But it may be that you can do something a bit more specific where you add cognitive demands to increase the load on the brain. The idea is that you adapt and then you become more resilient to mental fatigue.
Hi Sam, welcome to the Optimising Human Performance podcast. How are you doing?
I'm good. Thank you very much. Nice to see you again, both of you.
Always a pleasure. Thanks for coming on, Sam. Now, I've known you for a little while, but can you introduce yourself to the audience, let them know who you are, where you are, and what you do professionally?
So I'm Samuele Marcora. As you can tell from my accent, I'm Italian. In Italy, I did my first degree in physical education in the 80s. I'm very old. But then at the time, actually, there was no opportunity for people to continue their study in sports science in Italy. So I emigrated to the United States, where I did my master's degree in human performance. Came back to Italy for 1 year, and I worked at the Italian Olympic Committee in Rome, so working with elite level athletes. But I really wanted to do a PhD, so I moved abroad again in the UK, where I did my PhD. And then after my PhD, I stayed in Bangor for another 9 years as a lecturer first, and then senior lecturer. And then in 2010, I moved to the University of Kent as a full professor in sports science until 2020, when I moved permanently back to Italy at the University of Bologna, where I currently teach as professor of sports science. I also do consultancy for a variety of organizations. For example, I work with ASICS. I'm in the scientific committee of the Italian Cycling Federation. I've been consultant for Juventus, Arsenal. I've done some research for the STL, the MOD. And now that I'm back in Italy, I'm working with the Alpine Corps. We are doing some exciting research here as well with the soldiers.
Awesome. So Sam, obviously you're well known for a considerable body of work around this area of mental fatigue or cognitive fatigue.
Yeah.
So I suppose it's probably good to start with what is this concept known as mental fatigue?
Yeah, it's a concept that sometimes is a bit too broad. So I was a member of this NATO group on the biomedical basis of mental fatigue. I think we spent the first year just discussing exactly the definition.
I remember it. I was there. Yes, I remember those discussions.
Exactly. But that's also when you talk about physical fatigue. For good or for worse, it's a very generic term, and people use it when referring to very different phenomena. For example, we all know about muscle fatigue, which we define as a reduction in force production caused by exercise. And we call that fatigue, muscle fatigue or fatigue. But then there is this mental fatigue, which is completely different. And even within that, there is confusion. So like any kind of fatigue, you can differentiate two aspects of mental fatigue. One is the performance decline that you can measure objectively. And the other one is the more subjective effect of fatigue. And again, you can differentiate between mental and physical fatigue, again, in two ways. So you can define it when the fatigue is induced by prolonged mental activity, whatever is the negative effect, which doesn't have to be necessarily only cognitive or psychological. It can also be a reduction, for example, in physical performance. You can also define fatigue as mental, depending on the measurements that you're taking to evaluate, to assess the state of fatigue, which could be, for example, a questionnaire asking you, how tired you feel after working mentally for all day. Or it could be by measuring a decline in cognitive performance, for example, with the cognitive test. And on the top of that, there is a big confusion because the term mental fatigue or cognitive fatigue is also used when referring to the negative effects of sleep deprivation or sleep restriction, which is something that we try to differentiate. Sometimes the effects can be similar, and there is an overlap also in terms of neurobiological mechanism. But of course, there are two different things. For example, I can be mentally fatigued even if I slept very well the previous days. If I do something that is mentally demanding for like several hours, I'm going to be mentally fatigued even if I slept very well. Vice versa, I can have an impairment in cognitive function in the early morning when I haven't done much because I haven't slept very well. So as you can see, this terminology is used in many different ways. The way we kind of isolated the term for the purposes of our group, and I agree with this definition, we said mental fatigue is a psychobiological state that can be characterized both in a subjective way or in an objective way as a decline in performance, caused by, the technical term is time on task, basically spending a lot of time being involved in a mentally demanding activity. And by the way, in the lab, we normally use computerized tasks. So we know that the activity is only mental because they're not doing any physical activity. But especially in the context of a soldier, for example, a patrol or something that can have some physical demands, it's also mentally demanding. So in reality, mental fatigue is often mixed with physical fatigue, which makes it even more complicated. But basically, we are trying to isolate what are the negative effects of prolonged and demanding mental activity on your performance or on your psychological state, so your feelings of tiredness, lack of energy, perception of effort, these kind of things.
And how does it play out in terms of physical function then? So I know you did some work in the military over in the UK, combining mental fatigue and physical performance. Mm-hmm. What did you find?
Yeah, I was the first one to actually test scientifically, experimentally, whether mental fatigue, isolated mental fatigue, could have a negative effect not only on cognitive performance, which well established, but also on physical performance. So what I did in this study, it was published in the Journal of Applied Physiology in 2009, I artificially fatigued the participants by asking them to do a mentally demanding task on the computer for 90 minutes non-stop. And after that, they did a quite high intensity time to exhaustion test. So you go on a bike at a very high intensity, and then you cycle for as long as you can. It's a measure of, let's call it physical endurance, although there are a lot of very important psychological factors determining that. And on purpose, we did something very intense because we want to use something that traditionally is thought to be limited by things like cardiac output, lactic acid, this kind of thing. We've always thought it was a limitation, a physical limitation. So basically, we did this high-intensity endurance test after the mental work. And then in the control condition, before the endurance test, they watched documentaries for 90 minutes. So cognitive activity, they was not demanding, passive, so they were not mentally fatigued. They were a bit bored, but not mentally fatigued. And basically, we found a significant reduction in the endurance test. And the reduction was very similar to the one induced by leg muscle fatigue. So we found that the impact of prolonged mental activity on high-intensity endurance performance, which was always thought was limited from the neck down, let's say, actually the impact was as bad as pre-fatiguing the leg muscles on a cycling task. So that was quite, for some, I guess, a shocking result. But basically it was the first proof of something that, to be honest, if you ask any coach, when, for example, the team or the athlete is fit, is well-trained, is healthy, is eating well, but is not performing, they often say, he's not performing well because of mental fatigue. So the coaches, in an anecdotal way, sense that physical performance, sport performance, can be impaired by something that is not just physical. But there was no strong experimental proof, and also nobody has really quantified this negative effect. So that opened the flood for a lot of subsequent research as well.
You mentioned mental fatigue obviously impacts upon physiological performance, but how is mental fatigue going to impact upon cognitive function? What would you expect to see happening there?
There are two aspects. Of course, prolonged mental activity will eventually result in a reduction in cognitive performance. However, during cognitive tasks, it's a bit easier, I would say, to mask the reduction in, let's call it, efficiency of the neurocognitive system if you are motivated, Maybe we can talk about the relationship later on between motivation and mental fatigue and this kind of thing. But assuming that you're highly motivated to do well in the cognitive task, for quite a long time, you can compensate the negative effect on your functioning that we call mental fatigue by basically increasing your effort. So you compensate with increase your effort. This can also happen, for example, in physical tasks, endurance tasks, submaximal tasks, where you are fatigued, but for a while at least you are able to maintain the performance standard. But then you get to a point where you're so fatigued that you cannot maintain even a relatively simple performance standard, or which can be relevant, especially, for example, in combat situation, high stress situation. It may be that you're able to maintain the performance standard in a relatively simple task, but as soon as you have additional demands, physical and especially cognitive, then you're not able to address those demands, and then you are in a bad situation from a performance point of view. Because, for example, with some multitasking studies, you show that as soon as you add the demand there, when you are fatigued, you're not able to meet those demands, and then, of course, your performance is not adequate, and in a combat situation can be extremely dangerous as well. Of course, you will feel fatigued. You will feel that you have to put more effort to maintain the performance before your performance declines.
So, Sam, I'm going to take you through a scenario and I just want to get your opinion on it. Mm-hmm. Imagine then somebody's doing some kind of arduous course, a military course, a selection course. Mm-hmm. They are navigating and it's cloudy. They're at altitude or they're at relative altitude and the clag is set in, it's foggy, they can't see where they're going. Maybe it's a skill they're not that used to, or they've just learnt, they're relatively inexperienced at this type of navigation. And at the same time, they're covering kilometers. They've got a big weight on their back. Are we saying that the cognitive demand of navigating, of remembering certain things, working memory, trying to remember certain grid references, that kind of stuff, is that going to play out in their ability to contract the muscles, to get them over those hills, to get them across that route? Is that what we're saying?
No.
Okay.
Not in terms of the muscle function, ability to contract. Actually, we found that with mental fatigue, there's no reduction in either peripheral or central neuromuscular function. So you're not less able to generate force. However, for very intense efforts, up to, let's say, 30 seconds, a minute, which of course in the military, these are physical efforts that can be very important, mental fatigue is not going to impact much. But once you go over and above 30 seconds, 1 minute kind of duration, and the tasks become more endurance-based, even high-intensity endurance. So in those more endurance tasks, then there is a reduction in performance, but it's not mediated by a negative effect of mental fatigue on the neuromuscular function. What we found is that the negative effects of mental fatigue on endurance performance is mediated by an increase in perception of effort. So what you do feels significantly harder when you are mentally fatigued. And therefore, that will reduce your performance, because even the most hardcore physiologist would recognize now that perception of effort is a very important determinant of endurance performance. So your endurance performance will be reduced because of that kind of perceptual effect, not so much an effect on the neuromuscular system.
I've got it. I understand that. I used to love reading your Twitter arguments with other physiologists, Sam.
I cannot left Twitter, really. I'm not there much anymore.
No, I've not seen any for a while.
Yeah.
Just going back to what we're talking about then, the example then is cloud. You can't see much, but you've got mental load, you've got cognitive load because of what you're doing, your navigation. How about in a different scenario where there's almost information overload because of the environmental stimuli? So I'm thinking of places where you're constantly looking for danger, like slipping down things, maybe animals that you might step on and they might bite you, or that claustrophobic nature of you can't see that far in front of you because of all the trees and the foliage. Does that do the same thing? Do you get that perceptual overload because of all the information, the sounds, the smells, the things that you see? Is that potentially impeding endurance performance as well in a similar sort of way? Yes.
I just want to differentiate a bit. So the mental fatigue results from mentally demanding activities. You can go all neuroscience, but it's very easy. Any activity that when you do it, mental activity I'm talking about, that when you do it, it's associated with a feeling, something that you can perceive of effort, that you feel it is difficult, that's going to fatigue you. And most people in research, of course, because it's easier, they use cognitive tasks. So they use cognitive overload, where you have to pay attention for a prolonged period of time, which is something, especially in modern warfare environment, the soldiers, sometimes multitasking, cognitive multitasking, it's a form of overload. So, especially with the technology, I think it would be important for the people that decide to implement this technology to evaluate. Because often in psychology, you can have something that has both a negative and a positive effect. What you need to try to find out whether the net effect is positive. So you might have something that, okay, I give you an extra cue to attend on, and this may be very useful because, okay, you have an information that normally you wouldn't have, or it would be more difficult to get. So that's a positive thing, because it makes it easier for you to get this information, or they give you an information that before you didn't have, and that can be useful. But on the other hand, you have to pay attention to more things, and that's induced load. And over time, it can induce fatigue. So it's something that I think, especially with the implementation of technology, is something that should be not assumed that everything you do has always positive effect, can have unintended negative effects, especially when something increases your cognitive load.
Yeah.
However, what you mentioned in your example is something that's been studied less, and there should be more research. And you could argue that is a form of cognitive overload in a way. When you are in a situation where emotions are high, fear, I guess, the main one, anything like strong emotions, especially if you have to control them, like soldiers do most of the time, it can be mentally fatiguing. Then you could say, okay, it's the cognitive part of controlling your emotion, which we have evidence for, but the initial problem is that you have these emotions.
Yep.
But there is a nice study where they showed this video of an Asian woman vomiting and then eating her own vomit. So there are three conditions where they show you the vomiting woman eating her own vomit, and I call it the Italian group. And they told you can express your emotion. Obviously, the emotion there induced was disgust. Then they had the English group. So they told them, do not show your emotion, the stiff upper lip group. And then, of course, they had the control where they didn't watch any disgusting video. And they found that, especially in the English group, the people that controlled their emotion of disgust, there was a reduction in endurance performance. So it seems that controlling emotion, and even a relatively mild, the emotion on the battlefield is way more intense than watching disgusting, but okay, it's not nice, but it's not the kind of fear or anxiety or the other emotion that you can experience on the battlefield. Even controlling a relatively mild emotion had a negative effect on physical performance. So I think we need to not only take care of the cognitive aspect, but also the emotional aspects. The third area, which I think is very important, is motivation, right?
Yeah. I just want to say no one should try and Google that study just in case, because I've got a feeling there might be some weird things come
Actually,
up.
I found the video. I watched the video.
Yeah.
Someone's on it now.
Yeah, that sounds like not safe for work Google searches.
Yeah.
Just before we talk about motivation, I just want to loop back to, you mentioned you work with ASICs, and I remember hearing about and seeing the video of the ASICs, in the dark, where you're removing,
yes.
That sort of visual stimulus. Can you tell us about that study? What was it, and what did you find?
These were kind of experiments, if you like, but were not done to be published or anything. It was done more for television and marketing. But still, we set them up as experiments. And the idea was to compare a situation where the runners had, let's call it a rich motivation and information environment. So the crowd could cheer them. They knew the lap time. They knew the distance that they were covering. And there was light. Let's say a normal situation, competitive situation. In the other one, we deprived them of both motivational input, so the crowd was not cheering at all, only enough light to see where they were going, basically. And also we remove information about the distance covered. And you would say, of course, performance was reduced significantly. We cannot really isolate which was the factor, the reduced performance. But even more interesting also, from a military point of view, something that surprised me was the second event that we did. It's also amazing to watch on YouTube. It's called the Eternal Run. We fixed the pace based on the level of fitness, and we said, okay, now you run for as long as you can. And this was done in the salt flats in the Bonneville in Utah. So basically it's a flat desert, and you can run for miles. In fact, after a while, they all dispersed. and they were on their own. But the interesting thing there was that the only information they had was about the pace that they had to maintain. They didn't have any information about the time elapsed. We created a level playing field. Everybody was running at the same relative intensity. So the differences in fitness were, let's say, controlled. And Liz McCorgan, an elite endurance athlete, she won. She was the one that lasted the longest. She lasted a little bit over 4 hours running, which can tell you that it's not just the physical, but also the mental game that makes you an elite endurance athlete. But the funny thing is that she thought that she ran for like 90 minutes. She didn't have any perception of how long, even at a high-level endurance athlete. So that was very interesting to me, how much we rely actually on technology to have certain information. But on the other hand, the mental game, even in the complete absence of any input, that the person that is strongest mentally came out first.
Sam, I'm just going to swing it back to the neurophysiology of mental fatigue and like the underpinning causal mechanism. So do you think is it as a result of reduced neurotransmitters, so reduction in catecholamines, for example, or is it an energy availability issue, or is it a combination? Like what's happening? From a physiological perspective, it's inducing mental fatigue.
First of all, I would say it's definitely not energy availability. It's true that the brain consumes a lot of energy. In normal conditions, the main substrate is glucose. But unlike physical activity, when we engage in mentally fatiguing tasks, our energy expenditure doesn't go up. You can't measure it. Our brain does a lot of things above and beyond the bits of the brain that are involved in the cognitive tasks. And that consumes a lot of energy. So, for example, watching a documentary of doing a hard task on a computer, you cannot measure any difference in energy expenditure. Zero. If there is, it's so small that you can't measure it, even with very precise measurements. Of course, if you don't eat enough carbohydrates, you do very prolonged physical activity, and you get to a point where you're hypoglycemic, of course, your cognitive function is impaired. But really to become hypoglycemic, which with the minimum of carbohydrate supplementation, it's very easy to avoid. So glucose, depletion, these kind of things, no. In terms of neurotransmitters, originally mental fatigue was more associated with serotonin based on clinical depressed people, but serotonin doesn't seem to be the main neurobiological mechanism. So at the moment, the whole body of literature, clinical, animal, and the little bit that we have on healthy humans suggests that dopamine in terms of neurotransmitter and the dopaminergic system is the one that really is involved in the motivation and also the perceptual aspect, is increasing perception of effort that we were discussing, which is very interesting because the dopaminergic system interacts very strongly with another system, which is not really, it's not a neurotransmitter, it's more a neuromodulator, which is adenosine. So adenosine is a byproduct of energy production in the neurons. ATP, as you guys know, is the molecule that we degrade to create energy in any cell. And in the neurons, it can be degraded down to adenosine. When this adenosine is produced a lot, for example, when the neurons are active because you do this mentally demanding activity, this adenosine is then transported from inside the neuron, outside the neuron. It accumulates there, and when it's high in concentration, it binds to the receptors for adenosine on the neuron cell surface. And when this happens, the excitability of the neuron is reduced. It's thought to be some sort of negative feedback control system. So when the neuron is very active, it produces this substance that, as a result, reduces the activity of the neuron. So when you have this high adenosine in the brain level, this is associated with mental fatigue. And this is why the mental fatigue caused by sleep deprivation and the mental fatigue proper, so the one induced by prolonged mentally fatiguing task, there is quite a lot of overlap, because actually there is this overlapping mechanism, which is adenosine. Because the accumulation of adenosine is one of the neurobiological mechanisms for sleepiness and the cognitive impairment that you have when you are sleepy, when you're tired, when you don't sleep very much. Everybody knows the effect when you take caffeine. The net effect is stimulatory, right? It wakes you up, it makes you more alert, you feel less sleepy, also your performance is improved because your perception of effort is reduced. You know, all these things that we have associated with mental fatigue with caffeine are improved, but not because so much is a stimulant, it's because caffeine blocks the effects of adenosine. So the effect is stimulatory, but it does that by blocking the effect of an inhibitory substance. Okay, and this is why caffeine is effective both to reduce mental fatigue induced by prolonged cognitive tasks or even physical tasks. Also, it's very effective in reducing the negative effects of sleep deprivation because it has this blocking effect on adenosine.
Interesting.
Yeah, makes a lot of sense. I'd like to get your opinion, Sam. So caffeine is present in lots of drinks, obviously. Coffee, you're an Italian, you like your coffee, I know that. There are lots of drinks coming out at the moment, these so-called nootropics. And I want to get your opinion on them. When you're explaining caffeine, that makes sense because you've got that biological mechanism, there's evidence-based behind it. Now, a lot of these nootropics that are coming out at the moment, they've got all sorts of weird and wonderful active ingredients that supposedly will interfere or will improve your attention. There are a lot of them about take them at lunchtime because that's when you get that fatigue, that lull. You don't need caffeine. Take this instead. What do you think?
My opinion is that at the moment there is no strong evidence that they work above and beyond caffeine. And I also work with Red Bull, great company.
Other energy drinks are available, of course.
There have been studies where they compare Red Bull to a drink with the same amount of caffeine as Red Bull, which, by the way, is about a good cup of coffee, like an espresso. So they compare caffeine only, the same as Red Bull, against Red Bull. Everything, same glucose, same caffeine, one without the nootropics and one with, which would be Red Bull. And the effects was exactly the same. Also, these pre-workouts, there are a lot of these pre-workouts, things that you take before you go into the gym or do some sort of hard training. They tend to mix a variety of things, but there is always caffeine because caffeine is the substance that is highly effective. I think it'd be useful to study more of these. For example, I'm keen to study the combination of caffeine and tyrosine to see, for example, especially for people that are a bit too sensitive to caffeine, they don't like some of the side effects, to see whether we can either substitute caffeine or maybe have the same effect of a high dose of caffeine with lower doses of caffeine by adding something else. But I haven't seen anything convincing so far that there is such a thing.
Yeah, I'd agree. I'm finding it hard to find evidence. A lot of them have got things like lion's mane and ashwagandha and all these sort of novel nootropics, and I'm struggling to find robust evidence that there's a causal mechanism of why it works and then evidence that it does work.
No, caffeine, the evidence is overwhelming, and also there is a very strong biological rationale, which is the one that I described earlier, for its effect. By the way, there is some evidence that some of the positive cognitive effects of caffeine has to do with the bitterness of it, which is interesting. One of the things that actually I think is useful, and they did in the military, was the delivery of caffeine. If you ingest it, to reach the peak concentration in the blood, it takes half an hour. The effect is relatively delayed. But in a situation where you may want to have the benefits of caffeine quickly, they produce this chewing gum with caffeine, and the caffeine is absorbed at the mucosa, which is the lining of the mouth. So it is absorbed immediately. It takes about 10 minutes, 15 minutes max to reach peak level. I did a mini study just on myself. I went from London to Beijing through Tibet by motorbike. It took me 3 months. There was a lot of mental fatigue.
And broken bones, I remember you telling me.
Yeah, 5,500 meters with the bike. So a lot of stressors and a lot of fatigue. And I was taking these chewing gums throughout the day, some days placebo, some days chewing gum. Instead of just taking it at a certain time of the day, I was waiting until I could see that the tiredness was coming, and so I took it. The problem with relying too much on how you feel for mental fatigue, because the feeling is not so strong as the perception of effort that you have during a physical task, it's more difficult to read the symptoms. Sometimes you can have a negative impact on performance, on cognitive function, without people really realize how impaired they are. That's why a lot of accidents occurs, because people either push themselves too much. I think we all have done it when we should have stopped. Even before that, you can have an impairment in, for example, reaction time, stuff like that.
So Sam, that probably weeds in really nicely to our next question, in that can we potentially use technology to identify mental fatigue?
Potentially, yes. It's easier to identify the mental fatigue associated with sleep deprivation, because basically you close your eyes for some periods of time. So a lot of cars from the camera, they recognize when you're starting to get sleepy. So in terms of sleepiness, yes. In terms of mental fatigue, not induced by sleepiness, especially in combination with physical exertion, like it happens a lot in soldiers. then it's not easy at all. In those situations, at the moment, in a practical point of view, you can only rely on asking people to provide you the rating of fatigue, or based on your observation as, for example, a commander or something, because we actually found that you can have facial expression of these things, so you can recognize maybe mental fatigue or an increased perception of effort during task just by looking at people. A lot of people can tell whether a fellow soldier or teammate in sport is fatigued. Of course, it's not very precise. We can measure changes in brain activity with the EEG that are associated with mental fatigue. But even if you have a good EEG that worked on the field, to analyze this data, have a reliable measure at an individual level to say, you are fatigued. No. You may be able to notice even individual level when people are way beyond the point where they should have stopped or taken caffeine, you know what I mean? By the time we will be able to identify yourself, and also your commander probably would know already that you are fatigued. So it doesn't really add to the prevention of fatigue, put it this way. But of course, it would be very useful to have such a map. For example, I'm looking at some measurements with blinking rate, but at the moment we don't have a reliable measure, objective measure that can be applied in operation at the individual level, no.
Sam, can we loop back to motivation? You alluding to how motivation was important. Can we go back to that? So tell me about how motivation plays a role in how fatigued you are.
Yes. So, for example, coaches, they often associate signs of lack of motivation, lack of engagement, especially when it's unusual. They often say, oh, maybe the guy is mentally fatigued. It's true that mental fatigue may be associated with a reduction in motivation. I give a clinical example in depression. Obviously, fatigue is also associated with a lack of motivation, lack of interest for activities. I'm not saying that motivation is not associated with mental fatigue. It can be. However, it's not an essential component of mental fatigue. So you can be mentally fatigued and be highly motivated. And still you have a reduction in performance because of these kind of neurobiological changes. For the same motivation, you put, let's say, your maximal effort, but your performance, physical or cognitive, will be reduced when you're in a state of mental fatigue. However, of course, lack of motivation or even just boredom, some people say it could be a protective mechanism that is something to make you stop doing something for a prolonged period of time, maybe to prevent this excessive mental fatigue.
Yeah, so if we're thinking about how mental fatigue can influence performance, we recognize that it can influence performance negatively if you're too fatigued. What do we do? Like, if I'm going to give advice to someone who is going to be engaging in something that involves both mental fatigue and physical fatigue, how do we train them better?
There are 3 ways to reduce the negative impact of fatigue on performance. First of all, I want to say, so far we have talked about acute mental fatigue. There can be forms of chronic mental fatigue, things like chronic fatigue, Gulf syndrome. These are forms of chronic mental fatigue because from a physiological point of view, they are fit, but they cannot perform, they feel tired. And so there's also forms of chronic mental fatigue. So now we're talking about acute mental fatigue. So the mental fatigue induced by a mentally demanding task. They could be in isolation, like watching a radar for like 3 hours, or could be mentally demanding task combined with physical exertion. So for example, the foot patrol in a difficult environment, having to memorize things and lots of information, whatever. Doesn't matter. Any physical task has some cognitive demand. Of course, the larger the cognitive demand, the bigger the mentally fatiguing effects of that task, right? I think that's important. We call it physical and mental, but anything physical has a very strong cognitive and also emotional and motivational component, which can be mentally fatiguing. Okay, how do you deal with the acute mental fatigue? First of all, of course, the easiest on paper, sometimes extremely difficult to do, is to reduce the cognitive and emotional load of the task that you're doing. That could be done by providing some information. It could be training. If you are trained to do something cognitively demanding, it's going to be less cognitively demanding compared to when you're not trained in that skill or operating a device or whatever. So obviously you have to be careful when introducing new things, new skills, that people are prepared, because otherwise they're going to have a massive cognitive load during the operation, which is no good. For 2 reasons, by the way. One is going to be more mentally fatiguing, but also there is this cognitive motor interference. When the cognitive load is high, apart from the mental fatigue, which is kind of, let's say, a medium to long-term effect of having this mental load, you have an immediate effect. High cognitive load interfere with your ability to do physical task, and also vice versa. So that's immediate. So reducing cognitive load as much as you can, and sometimes it's almost impossible, but what you can do in training to prepare the soldiers to reduce the cognitive load, or with technology during the operation, top strategy, obviously. But sometimes the obvious things are overlooked. The second one, for which we have less evidence, we call it brain endurance training. As I said, physical training is mentally demanding. So when you do the physical training, you also train people to be more resistant to mental fatigue. But it may be that you can do something a bit more specific, where on purpose, during training, on the top of the classical physical load that you have with training, you add cognitive demands with the cognitive task, by making the training environment more emotionally demanding. You do it in training on purpose to increase the load on the brain, so that the idea is that you adapt and then you become more resilient to mental fatigue. For example, it's more difficult to mentally fatigue elite endurance athletes than recreational endurance athletes. We don't know if it's the training or if it's the genetics, but we found that highly trained athletes are more resistant to mental fatigue. Maybe genetic, but it must also be the training that they do. And you can do this brain endurance training, so adding this cognitive load. And you can do it in many different ways. It could be when you do the marching, somebody shouted words at you, you have to memorize them. You can do maybe a cognitive task in the resting periods of interval training. So if you do intense interval training, okay, you do your intensity bout, and instead of relaxing in between the bouts, do some demanding cognitive tasks. So there are many different ways that you can add cognitive load to the training load. So this is in terms of training. And then, of course, the other one is to strategically use, which I know even in the British Army, despite all the research, is not done in a systematic and scientific way, is a really strategic, well done, properly educated use of caffeine. Because caffeine is effective. I think we need to do better in instructing and giving the people the right information and right strategies on how to use caffeine strategically to improve performance during operations.
So can I take you through a scenario and again get your guidance? Imagine then you're being asked to support someone who they've told you they want to go on an arduous course, a military course. They're trying to get into a certain unit that requires them to do endurance-based activities. And so far, all they're told is put weight on your back and walk up and down steep hills. Now, they've listened to this podcast and they're thinking, right, I need to think about mental fatigue and brain endurance training. What does that look like in terms of how long is the cognitive task? They do it every half an hour, do they do it every hour? Let's say someone's down on Dartmoor, they're about to go for a long walk over the moors. Do they stop every hour and do a little memory task? Is there a gold standard, or what's your opinion?
Yeah, well, ideally, I think it would be something that you do continuously during the operation. So like not always, but often is in the real operations where you're often cognitively engaged for a prolonged period of time. And you don't need necessarily fancy technology. It could be that, I don't know, every few minutes they tell you a word to memorize, especially if they're long, and then you have all these words to memorize, and you have to keep in your working memory for a long period of time. Of course, you need to motivate them somehow to do it. For example, at the end of an hour, 2 hours, whatever, they have to write it down, as many words that they remember. And the more, of course, the better the performance. And motivate them somehow. See, with the physical task, it's much easier though. You say, okay, you do the fucking task, and you know they've done it. With the mental task, it's not the same as the physical task to force a load on people. Basically, you need to motivate them to do it so that they engage with the cognitive task.
Yeah, I'd hope if somebody is volunteering to do something quite difficult, to go on an assessment or a selection type course, they would be suitably motivated to do these things. Because what it sounds like to me, what we're talking about is, if you do this type of training, it's probably going to just nudge the odds that you're going to be successful at the test that you're doing. It's preparing you better to go into the environment where you will be tested both cognitively and physically. So if you are motivated to pass those tests, this makes sense that you train this way.
Yeah, the test or doing this, you'll be better prepared in the real operational scenario where you may actually risk your life.
Yeah, for sure.
Because your reaction time is reduced, your ability to memorize things or to recognize. Actually, the very first funding I get for this kind of research from the MOD was not about mental fatigue at all. The call was about how can we improve the ability of soldiers to recognize the basic cues of IEDs in the environment. I'm talking about a long time ago, so Afghanistan, Iraq, there was a major problem, right? Most people would just say, okay, a new technology. And I say, no, I'm not going to improve their ability to recognize the cues. I want to reduce their mental fatigue so that at the end of the patrol, maybe they recognize a cue that if they're fatigued, they don't recognize. So becoming resistant to the negative effects of mental fatigue literally could be a question of life or death. And I think soldiers should pay attention to it as much as the physical training. The good thing is that doing physical training, I think, will improve that. But if you can do these other things that we discussed, both in terms of training, skills, preparation, use of caffeine, maybe use of some psychological strategies to overcome the negative effects of mental fatigue, like you do, for example, in endurance sports. So those are things that may really make a big difference over and above what you already do anyway. And some of these things don't need to take more time. You can do it within the physical training.
So when you think about the modalities of training, there's one modality, one sport that pops out time and time again in this regard, orienteering.
Yeah, exactly.
Which is obviously has a physical component, but then this cognitive component, situational awareness, working memory, decision making, and just a bit of fatigue. You could put a competition in there, i.e. do this course a set amount of time or you're going to go again.
You weren't particularly good at orienteering once in your life, were you, JP, by any chance?
Funny enough, mate, I did partake in a bit of orienteering for certain organisations, yes.
I thought so. I thought you'd swing that one in.
No, absolutely. Orienteering in physical exertion is useful anyway. For soldiers, probably they do it anyway, but it could be maybe done a little bit more systematically to have these benefits in terms of resistance to mental fatigue.
Sam, that was a strap on my orienteer more. That's it. Boom, done. Orienteer more.
Sam, I appreciate you're a very busy man and we've been talking for a while now, so I'd like to wrap up the episode. What I'd like to do is offer you the chance to wrap it up for us. So can you give us something maybe that you've not spoken about that you feel is particularly important, or maybe if there's any key messages that you just want to reiterate? How do you want to close off for us?
I think we cover most things. The reiteration I would like to give is that, especially to people that deal with physical training, also pay attention to the mental side of things, including mental fatigue, and try to incorporate it in your training in an effective manner that you don't necessarily increase the time devoted to training. Physical training, but also skill training, these kind of things, but that you may prepare your soldiers, your pilots, whatever, better to resist the negative effects of mental fatigue during operation. I think this could really give an extra edge to your force, to your people under your care. The other thing I would like to say that I miss you guys in Britain, and hopefully I will come and visit you soon.
You're welcome to come back and enjoy our food anytime you want, Sam.
Believe it or not, there are some things I miss a lot. Fish pie, I love, and something that I would never believe that I would have liked. I resisted even trying it for years. Then once I say, okay, fuck it, I'm going to try it. And then I loved it. A chip butty.
A chip butty.
A chip butty. You come from Bologna where you got mortadella and some of the best food, and you want a chip butty? What?
I love. So a good chip butty, and Betsy Coed in North Wales, there is a mountaineers place, and they do an amazing chip butty.
There you go. What a way to end the episode. We've had performance nutritionists on before. I'm not sure what they'll make of that, but have a chip butty in North Wales if you ever visit there. That's
Here
awesome. Sam, thank you very much for your time. As always, a great conversation. Really, really appreciate it.
You're welcome.
If anybody does want to follow you or look at what you're up to, what are the best ways of people connecting with you or just following your work online?
Yeah, of course. They can reach me by email on the website of the University of Bologna. They will find all the contacts if they're interested.
Yeah, we'll get those in the show notes so people can reach out if they've got any questions. Again, thank you from me, Sam. That was awesome. And come back to the UK soon.
Thank you. See you guys. Bye-bye.
Cheers, mate. Thank you.
That's it for this week's episode of the Optimising Human Performance podcast. Thanks for tuning in. And if you found this valuable, take a moment to rate and review the podcast. If you know someone who'd benefit from today's conversation, then please share this with them. We're always keen to hear your thoughts. If you have feedback, guest suggestions, or topics that you'd love us to cover, then email us at info@ophp.co.uk or connect with us on LinkedIn. Until next time, keep striving, keep improving, and keep optimizing your performance.